Welcome everybody to Reactive Relational Database Connectivity. One information as a heads up, we swapped earlier the rooms. So initially this talk was scheduled for 11 AB, and we just switched the talk with the talk that was supposed to happen here. That being said, welcome to the session. My name is Mark Paluch. I'm working with Pivotal as Spring Data project lead. I'm also a contributor to the R2DBC project. And this is what we are going to talk about today. Now, as you might probably know, we announced R2DBC, which stands for Reactive Relational Database Connectivity. Last year, it's SpringOne, which is a specification that was designed from ground up to cope with SQL database access for reactive programming, because there is up to date no release, no viable option for a broad set of databases to be accessed from a reactive programming perspective. As you might know, today's standard for accessing SQL databases is JDBC, and JDBC is fully blocking. So we had to come up with something different than that, and that's how R2DBC was born. With that in mind, we initially designed R2DBC to be as lightweight and as adoptable and accessible as possible. The only two dependencies that R2DBC has is Java 8 itself, because we wanted to leverage the functional programming model, and reactive streams. And reactive streams to be able to leverage some interop API on the JVM. And as you probably have heard, the reactive streams specification went into Java 9 and newer. So effectively, R2DBC is dependency-free once R2DBC goes on Java 9 and higher as a baseline. R2DBC had a series of design principles established up front. So one and the most important bit here is that R2DBC embraces reactive types and reactive patterns all the way down from your application layer down to the database, leveraging reactive capabilities of databases, such as accounting for not sending all the data at once to your client to overwhelm it, but rather take things like backpressure into account. It is a fully documented specification, not just a bunch of Java class files, but rather it tells you what you can expect from R2DBC as a user of that SPI, and what you have to provide if you want to implement a driver that is compliant with R2DBC itself. It has a very minimal surface, which is not really an API, but rather a SPI, which stands for Service Provider Interface. And the idea is to dedicate R2DBC only a single purpose, which is that driver vendors can implement that SPI and clients can consume that SPI. It is not intended for direct use within applications. Why this is, we will see in a minute. But it is also an enabler for client library authors to build on top of R2DBC, so that they can build on top of a SPI where you can interchange drivers underneath. So similar idea like we have with JDBC. Although JDBC serves multiple purposes, it abstracts the database away, but it also serves the purpose to basically be usable from the application side itself. And we do not want to do that because in such an arrangement, drivers have to implement user-specific features, user space features, and we consider that should be rather an aspect of client libraries themselves. So how does R2DBC SPI look? So a brief look on R2DBC will show you that the ConnectionFactory is the entry point to every driver implementation. And as the name already suggests, it is a factory for connections. Once you want to obtain a connection, you ask the publisher to subscribe, and once a connection is ready for being used, after handshaking, doing all the connection phase, then you get hold of the connection. You also can get hold of a little bit of metadata. This isn't really necessary for user interaction because typically you know which driver you are using, but for client library authors, this contains valuable information about things like dialects, which dialects to use. Once you get hold of the connection, then you see a lot of methods returning publishers, and this is to interoperate with transactions, with save points. Basically, SQL databases are all about transactions, right? So this is the interface to operate with these, and for us application developers, only two things are of interest. One is the batching functionality, and the second one is the creation of statements. And this should also give you an idea that R2DBC is really not intended for direct use. You can use it, but it's for sure no fun to work with bare-bone publishers and the SPI itself. Rather, watch out for a driver, for a client library that suits your needs and that helps you solve your business requirements, and that builds on top of R2DBC. That's the idea here. Now, if you have followed the R2DBC development, then you have probably seen that last year we have released 1.0 milestone 6, and the most recent version is 0.8 RC2. And this is not traveling back in time, but rather R2DBC was a constant learning for us about the requirements and a proper design of such a service provider interface. And what we realized is that you don't build an SPI within a couple of days or within a year, but it takes a little bit more than that. So we relabeled our releases to the 0.8 release scheme to indicate we want to go towards a GA release, but we can't promise full backwards compatibility on the SPI, but rather we know about a few upcoming things that will require changes to that SPI. And once we are happy with perhaps an 0.9 release, and we can relabel it to 1.0, then we will see a fully stable and backwards compatible release of R2DBC itself. So we had a change in the versioning scheme. Besides that, R2DBC introduced categorized exceptions that tell you exactly what went wrong if you had a bad grammar error, or whether you tried to insert data and you violated a unique constraint, these kind of things. R2DBC features a discovery and configuration story in terms of class path-based and Java Service Loader-based driver discovery, where you specify a connection string, and then R2DBC itself will go to the driver, configure it for you, and you will get hold of the ConnectionFactory. We have connection validation, which is in particular useful for things like health checks or connection pools. It has blob and CLOB, so large character and binary support, where you can stream the large chunks of data rather than consuming them as a huge memory page. R2DBC 0.8 ships also with a few SPI refinements that make it a little bit nicer to use in that places where R2DBC shines through into user space code. It ships with a connection pooling component and a series of new drivers. There's support for the H2 in-memory database. There's a community-driven driver for MySQL. There's a SQL Server driver. The SAP HANA driver is currently under development, as well as the Google Cloud Spanner driver. And the entire ecosystem around R2DBC is growing. So this is something which proves us that there is interest and there is need to drive R2DBC forward. And we will continue to do so. Now, I was stressing a little bit that point about a humane client. So see, using R2DBC SPI itself is no fun on its own. And I think the same applies for JDBC, because you have always to take care of SQL exceptions, open resources, close these. And this is probably not the domain that you are working in, right? But rather you're working with customers, with transactions, with orders, with something which is tied to your domain. So therefore we found, hey, let's build something that helps our users to do exactly that and achieve their goals by leveraging something which is fully reactive And that helps them with a convenient and fluent API to express what they want to access and how they want to access. And so we came up with the idea of, let's build a Spring Data R2DBC on top of R2DBC itself. And the entry point to Spring Data R2DBC is the database client. You create it by using a ConnectionFactory. And if you are already familiar with the web client from Spring Webflux, then you will notice certain similarities across the web client and the database client. The web client is, as the name already says, for web requests, and the database client is associated with database activity. It features a fluent API, and to execute any arbitrary SQL, you call the execute method, put in your SQL string in there. You are able to use named parameters. You can bind these values to placeholders, and then you express basically the way how you want to consume the outcome of that query. So in this example, we are mapping all the resulting rows to the person class. We are fetching all rows, and that's why we get a flux of person. We could also fetch just the first one, so we would get then a mono of person or just a single one. And if we encounter more than one result, then the mono would basically terminate with an error and say, express that it has received the incorrect number of rows, to give you certain guarantees so that you do not need to add these specific checks within your code itself. But really, the database client is just the foundation of what Spring Data R2DBC can provide to you. It compares a little bit to what you get back then from JDBC template. So it's very the lowest layer that manages resources for you, and that provides entry points to the specific functionality that you want to achieve with the database client. On top of the database client, we build reactive repositories, R2DBC repositories. And the idea behind that is, if you are already familiar with JPA repositories or imperative Spring Data repositories in general, then you might already know the CRUD repository. And if you want to use R2DBC in a repository pattern, then you derive from the reactive CRUD repository interface. That gives you the full control over your queries. You can either use the methods which are provided by the CRUD repository itself, find by ID, save, find all, delete by ID, these kind of methods to create, read, update, and delete your rows. Or you can add your custom own query methods by using the @query annotation with the same level of convenience, that you can put in named parameters that are bound from the method invocation itself. And then within your own code, you just invoke that method as any regular other method, so you don't see any real difference. Now, what does R2DBC, Spring Data R2DBC really give you? So it is a very functional-oriented API that allows you execution of arbitrary SQL, like we have seen with that select statement, but it also has more qualified methods that will guide you through selecting data using a criteria API, through inserting data, either entity-oriented or key-value tuple-oriented. The same goes for updates, that you can specify an update. In the same way, attach a criteria to that to filter the update itself and delete that data. So basically, all these 4 primitives that a SQL database can give you. And if you require more, then you are free to do so by just using then the execute method. And there it really doesn't matter whether you use parameterized or unparameterized methods. Spring Data R2DBC will guide you through that. It has support for reactive transactions. We will see in a minute an example how this works. So finally, reactive transactions are possible. And if you have attended the keynote and Jürgen's talk on Spring Framework 5.2, you've learned that R2DBC is only one of the components which supports reactive transactions. There are a couple of more of these, like MongoDB and Neo4j. I mentioned already the name parameter support, the repositories. You can use Kotlin coroutines together with Spring Data R2DBC as suspendable functions for single row results, or the flow data type to return a stream out of data. So you have all of these possibilities and choices. Now, let's dig into a short demo to see how all this looks like and how all, this feels like. Now, what do you need to get started with Spring Data R2DBC? So there is a Spring Boot R2DBC project which provides you the configuration experience. And you basically go to start.spring.io, select the latest Spring Boot version, and then you go with R2DBC. And there is a starter for Spring Data itself, along with all the drivers that are supported and shipped through start.spring.io. I did that already. I pulled in the Spring Boot starter for R2DBC, for Webflux, and the H2 in-memory database to get me started. And what I have here is a little bit of setup. A Pojo to represent the person with a ID field. This ID is auto-generated by the database upon insert. It has two fields, first name, last name. And there is also a person event class, which represents events around activity for the person event itself. But we will come to that one in a minute. Besides that, you just declare a repository, right? So as already mentioned, you declare a repository by extending the Reactive CRUD repository. And then you get a base implementation for various functionality, such as the findAll method, which will return for us a flux of person. No, not throw, but return it. And then once this is done, I can start my Webflux application. Here we go. And let's query it. So the query goes to the database. The data is already pre-populated, so I have 3 records in it, and this shows me basically what my database contains here. Now, this is the findAll case, but I probably want to do more with that. Something like find by last name. So all I have to do for that is declare a query method, annotate the query itself. It selects asterisk from person, where last name equals the last name parameter. And this parameter is basically passed through as a path variable. So let's take this, execute by name, and see what we get for Schrader. Okay, this works. If I misspell the name, then I don't get any data at all. So this is already cool. And this would be the repository approach, how you would select all the data. Besides that, I can use also the database client directly if I want to do so. Spring Boot R2DBC extensions already configure a bean of the database client type. And let's select from the person type, right? And then fetch all to basically do the same thing that the repository is doing. Okay, and let's run it and try whether we see the same example, the same data. And here we go again. So there's basically no difference, and the only difference is in your preference and the things that you want to do. Sometimes the database client offers you much more convenience and much more flexibility than a repository, but this really boils down to what your use case requires. Now, let's get into a more transactional approach, because what we have done so far is just selecting data. Now, what I want to do is inserting data, so creating new records. And to do so, let's use the person repository, save a new person. The first name and the last name also originate from the path itself. We do not want to have any result on that, so monovoid basically means notify me as soon as all this activity is done. Restart my application. So we have still these 3 records here. And to create another one, I will have to post to my endpoint, create this one, goes Spring. Hopefully this is correct. Yep. Now let's check whether it was added. Yeah, it was added. So this is the simple way how to create data. But now, really, what I want to achieve here is tracking what happened about the person itself. So I have this person event domain type. What I didn't show you yet is this events endpoint. So this is currently not implemented. So let's do that quickly. Return person event repository find all to implement that. And upon person creation, I want to also persist the person event, right? So let's do that and save the event itself. Make sure that we don't return any data from here. Restart the application. So events is currently empty. Let's create my friend Spring. Then we see there is an event in. Cool. So this apparently works, but there is some issue to that. So what if the second save fails? Because probably I assigned an ID, which is duplicate on the second insert, right? So I currently use a different constructor to populate the ID so that it will create a unique duplicate key exception once I add the second person, right? So let's take another one, Flynn White, to have 2. And what I see is an error, right? Which says there's a unique primary key violation on my person event table. Now let's inspect what actually happened here. If I list the person table, then I see there's Jesse, Hank, Gus, and Flynn. If I list the events table, then I see only an event for a single event, right? Because the second write failed, since I wasn't using the transactional scope. And this can become a problem, because you want consistency, right? So therefore, we need to discuss how we can ensure consistency with Spring Data R2DBC itself. And we want the same style of same way of convenience and the same level of consistency that we get today from imperative applications. Thing is, if you look behind the scenes of transaction manager implementations, you will realize that these implementations are thread bound. So all the transactional state is kept in a thread local variable. And this assumption that code stays on the very same thread is no longer given in the reactive context itself. The reason for that is we typically do not think about threads so much in reactive programming from an application developer perspective. These things happen, and they happen for us, and thread switches happen at arbitrary points in time. So therefore, we cannot rely anymore on thread local storage. So we have to put our transactional state somewhere else and attach it to something that is bound to the thing that we actually want to execute. So although the pattern with begin, commit, rollback is correct, we need to translate that into a reactive style. And what we did is we leverage the reactor context, which is a storage that is attached with to the actual subscription or materialization of a publisher. Once you subscribe to that publisher, the context gets propagated through to all participants. And if you have multiple publishers, all these can see and use what is inside of the context. And that's what the Reactive Transaction Manager implementation is doing. And we implemented with R2DBC, Spring Data R2DBC, the R2DBC Transaction Manager. And this is basically all you need to enable and opt in to reactive transactions with Spring Data R2DBC. Once you have this been set up, then the Spring Boot support will configure the Transaction Manager support, create proxies where it's required, and set up also a programmatic facility for transaction management. Now, the Reactive Transaction Manager looks mostly the same as the Platform Transaction Manager, method-wise, because you want to retrieve a transaction state, you want to commit and roll back the transaction, right? So the pattern still stays the same. The only thing there is which changes is the return types, because you are talking about publishers and you can attach only a context to something that returns you a reactive type. You cannot attach the transactional context or the reactor context to something that returns you a string or a void. This isn't going to work. Now, let's get back to our demo. What do we need to do in order to get consistency? Well, there's probably one thing we can do, which is putting at transactional here, and then restarting our application. So let's do the very same example. Create Flynn, now create Gus, and then on Gus we will see that exception. Let's inspect the person table, and what we see here, we have Walter, Jesse, Hank, and Flynn, but Gus not, because the inserting the row into the event table failed, and so the entire transaction was rollback. And it is as simple as that. So if you use already at transactional today on your services, then you can use it in the very same way with reactive transactions. And the transaction aspect support inspects actually the method signature. And if it sees a known reactive type, like a mono, a flux, a publisher, or if you're using Kotlin and the flow type or a suspendal function, then it will automatically apply transaction management in a reactive way to that method. For all other return types, it will fall back to the imperative transaction management. So this is the annotation-based model. There's also a programmatic one, and to enable that, I need something different up here, which is the transactional operator. Let's get that injected. And what we do in order to get programmatic control on for transaction is use this transactional operator, transform our mono as transactional, and that's it, right? So let's restart our application. Do the same example. Now Gus was successful, Flynn will fail. And if we inspect the person table, then we see basically the very same behavior. The first added record is there, the second one failed, and the transaction was properly managed. You can also choose a more callback style approach to call the execute method and put in all your work in there. But we've really found that the first example that I showed you, it reads much nicer than the Lambda form above, and it follows the very same fluent style how you have how you would do and apply operators to your reactive programming model. Now, the question that might arise from here is, what is part of the transaction itself? If I put yet another line in here, then what's part of the transaction actually? So, as a rule of thumb, here this RxTX transactional affects all upstream publishers. So everything that comes before this line is in the scope of the transaction. Everything that comes after is outside of the scope of the transaction. So this is a good rule of thumb. So this was the part about transactions. Okay, we've seen that. We've seen programmatic transaction support. There are, however, some caveats to reactive transactions. So the context feature in Project Reactor is not part of the reactive streams specification itself, which means that this is a library-specific extension. And if you are using other implementations of reactive streams that do not propagate the context, then you basically can lose the context and the transactional state. So, so if you use anything other than Project Reactor, then your transactions might break. It's not guaranteed, and in most cases it can still work, but this is something we need to put additional effort in stabilizing or at least helping you to know where the transaction can begin and at which point in time the transaction can be gone. So for the beginning, a recommendation, if you want to use reactive transactions, stick for the beginning with Project Reactor only. Another thing that we've seen during the development is that transaction cleanup can happen asynchronously. So while all these steps have a time dependency, so you have to begin before you start with your work, and you have to commit after you applied your work. The cleanup itself can happen in a synchronous way in cases if you cancel the transactional stream, which means the cancellation is a signal that tells the upstream publisher, okay, I have received enough data, I don't need any more, now I can progress from this point on myself. And this will cancel the upstream transaction and the upstream subscription, which means that the commit will happen, but you are not awaiting the commit. And so if you do two of these steps, the first transaction, canceling it, and then a second transaction, you might not see the changes applied in your database. So as a guideline, we recommend not canceling the stream in the sense of using operators like .next or take, because these operators cancel the upstream publishers, and you lose the ability to retain synchronization. Let's talk about configuration a bit. So a really neat feature of JDBC is this connection string pattern that JDBC has. However, JDBC does not specify how the connection string continues after the JDBC double column. This is the freedom of every driver developer to do whatever they want once the JDBC double column prefix has been reached. And every driver developer does their own thing. And this makes it really hard to migrate these URLs between drivers. So if you want to use H2 now and tomorrow MySQL or Postgres, then you have always to look up in the manual how this connection string gets constructed. We thought, let's stick to the good pieces of what JDBC provides, with this general idea of a connection string that you can use to configure your infrastructure. But let's do all this URL parsing within R2DBC itself. And then at the boundary, at the interface where it goes into the driver receives a configuration object that it can evaluate, so drivers are not bothered with parsing connection URLs. And by doing so, you get a lot of benefits from that. You get a standardized format. The driver itself does not need to deal with URL parsing. And you can enhance all these information that you get from this connection URL. The typical use case for that is, well, I want to specify my driver and my endpoint within my connection URL, but I do not want to put in the password and the username. I rather want to inject these information from a vault, from a secure source, or from some other place, and keep the URL itself portable and public. And that's what what R2DBC itself provides in its core, this connection URL parsing functionality. And Spring Boot itself builds on top of that to provide a configuration experience similar to what we have today for JDBC. You specify Spring R2DBC URL, which is then the URL. You have properties for usernames, passwords. You can inject your own functionality and properties into that, and so you get a fully configured ConnectionFactory. You can use that ConnectionFactory either with Spring Data R2DBC or any other R2DBC client. You get the R2DBC Transaction Manager support configured. It has support for the H2 embedded database, and if you use H2 from R2DBC and JDBC, both facilities are pointing to the exact same database to give you the best experience that you can apply things like database schema migration tools to your database from the JDBC side and use and consume the data from H2 through R2DBC repositories or the database client. Spring Boot Starter for R2DBC has also support for the actuator, so you get health checks and metrics. It has support for schema SQL and data SQL files, so you can set up your schema and database. So that's basically what I did earlier for this example, to pre-populate my database, create the tables, create the data in it. It ships also with a data R2DBC test annotation that allows you to bootstrap test slices for R2DBC functionality only. Now, as already mentioned, you can bootstrap your own project by going to start.spring.io using Spring Boot 2.2 RC1 or the snapshots, and then you can use R2DBC with the Spring Data Starter and the database drivers for MySQL, H2, Postgres, and SQL Server. And then you basically get started with your project. Now, let's take a look on the R2DBC ecosystem. So when we started like 2 years ago with the R2DBC idea, we basically were looking for an answer. Is reactive programming and SQL database possible at all? Or is it just something that we will never reach? It started with the first implementation, which was the Postgres implementation. And once we found that this is possible, but it requires entirely new drivers, which have to rely on a non-blocking communication infrastructure, we began to evolve the efforts around R2DBC itself. We created the R2DBC specification, which is the SPI. There is a specification document. We have received a huge contribution in form of R2DBC proxy, which gives which basically fits into the observability and metrics picture, in the sense that you can plug into the R2DBC system itself and observe it, which queries get executed, how long it took. You can export these data to Micrometer, to Zipkin, or you can build your APM tool on top of that. We have connection pooling component, which makes usage of database connections really cheap we are no longer required to reach out to the database for every SQL statement to create a connection, but rather we can leverage the connection pooling component to reuse connections across the entire lifecycle. There's an entire driver ecosystem which is emerging. Already mentioned Google Cloud Spanner and SAP HANA drivers, which are currently in development. The H2 driver, you've seen it already in action with my demo. There is a Microsoft SQL Server driver. There are two MySQL drivers. One is a native one. One is a bridged one using a Kotlin driver. There's a PostgreSQL driver. I'm going to show you also a cool feature of Postgres, what we can do there. There are client implementations like the Spring Data R2DBC client. There is the R2DBC client itself, which isn't really a reference implementation, but it is an implementation inspired by JDBI, which is a very lightweight JDBC client library that allows you to focus on the actual SQL that you want to run. And there is another one which I cannot pronounce, so I'm not going to try that, which is written entirely in Kotlin. So there's a little bit more to the R2DBC story. Since we weren't the first folks who wanted to have a non-blocking communication layer to SQL databases, there were already existing efforts, like with NDBC, which provides connectivity for MySQL and Postgres databases. There is this JAsync driver, which is a Kotlin-based driver, also for MySQL and Postgres. Vertex is running since quite a while a few of these drivers. Now, Oracle also realized that there is demand for an async API for database communication, so they eventually came up with a project called ADBA, Asynchronous Database API. But eventually they canceled it, realizing that they are having shifted their focus more towards Project Loom, which will enable blocking I/O to behave somewhat like non-blocking, in a sense that you do not occupy threads anymore. But the nice thing, which also popped up as a side effect of that, is that we were constantly in contact with the ADBA team, and they had some difficulties understanding what we want from them, and probably we had also some difficulties understanding them what they were aiming for, because they were aiming for a pure asynchronous API that is working with completable future. Our main focus is reactive programming. And although there is some sort of overlap, it isn't exactly what we need. Now, we have learned also from announcements from Oracle that they are going to ship their Oracle JDBC driver 20 with several reactive extensions, which look pretty much like what we have in R2DBC itself. So it will be quite sophisticated exercise to wrap the JDBC driver 20 once it's there behind R2DBC, and then just use it. And then you would have from day one a production-ready driver, because you do not need to reinvent the wire protocol, but rather you just wrap what the driver provides to one, and then you just consume it. Now, what's a roadmap? So R2DBC started in early 2018. It proved to work, and we also learned that there is some demand to make R2DBC happen in the sense of bringing it to general availability. As of today, we have a release 08 RC2, which is the second release candidate of the O.X line. We are looking forward to transition R2DBC into a sustainable maintenance model, because all this still started as an experiment, and now we have to find a model how we can sustain the maintenance, how we can bring R2DBC into production, and we expect to release a GA release of O.A later this year. We also know about things that we want to include into an O.9 version. So we learned that stored procedures are still a thing, people are still using stored procedures, so we want to support these. We have learned that certain databases have requirements about transaction attributes that aren't necessarily possible today with the current design of R2DBC SPI. So we are going to add support for extended transaction attributes for databases which support these. And these can be things like read-only transactions, read-write transactions, these kind of things. And we also learned that the reactive programming model is very strong in regard to events. So we want to introduce an event provider API that allows a specification for databases that are able to publish events. And this is actually something which is pretty cool and pretty easy to achieve with R2DBC itself. So who of you is using Postgres? Quite a few. Cool. So Postgres has this nice, it has actually two pretty decent functionalities that allow consumption through a reactive way. The first one is the listen notify functionality, where it basically provides a pub/sub mechanism for messages. So you emit a message and then you can consume that message. And the second thing is logical decoding, which basically is streaming of replication data, so change data capture. And what I want to show you today, right now, is how you would consume the listen notify functionality from Postgres. So since this is a Postgres-specific functionality, after injecting the ConnectionFactory into my controller, I need to get hold of directly of the Postgres connection. So this is then the driver-specific API. Once this component gets constructed, I'm subscribing immediately to a channel, which is listen to login event notification, subscribing to it to set up my listening. And what I want to do now is walk you through that implementation, how I would basically produce these events and consume them. So what I want to do is I want to have the use case that I'm triggering login events, and I'm listening to a stream of login events. So that's the use case. Now I have this login event repository already prepared. So to persist a login, let's save a new login event. Take the username that we get from the path variable, and as you probably have learned, I'm loving path variables because I don't need to deal with JSON and these kind of things. And add a local timestamp. Put a then behind of that because we do not want to reuse the saved login event, which might be associated with the ID. We just want to acknowledge, okay, this was saved. That's the first thing. Second functionality that we have here is this logins endpoint, which will give us all the logins. This is already implemented. And the last thing I want to use is getting hold of the event stream. This event stream is exported as server-sent events, SSE. So I'm producing this media type text event stream. And all I need to do is the connection has this get notification flux, right? So this is a stream of notifications. And the notification in Postgres contains three information: the channel, the process ID, and the actual payload. And what I want to output here to the stream is the payload itself. So return notifications, map the parameter, and that's probably it. So where's the magic here? So the magic lies within Postgres itself, and to leverage that functionality, what I've set up is a little bit of infrastructure code to have a notification function, so a server stored procedure. We have a table, and we have a trigger. So these are the three ingredients that we need. We attach the trigger to insert operations and update operations. So every time we are inserting data in our login table, we get that event emitted, and the event basically takes the row, transforms it to JSON for simplicity, and it emits that to this login event notification channel. So that's basically what this setup is doing. Now let's start it. Cool, application is started up. Let's listen in one window to the login stream, and in the other one, let's basically create logins. So let's create a bit of space here. Login, let's do GAS. And as you see, me typing and entering data here, we see in the second window that we get events emitted, which is basically listening to the event stream. And this can go for, on and on for as long basically as we are connected to the database. In the meantime, we can also query the events table or the logins table. And then we see, probably not the best idea to have it colored. And then we see we have inserted a couple of rows. Gus is already here with the appropriate login time. Flynn is here, and so on and so on. And really, consuming this pub/sub stream from R2DBC is a very natural fit because we don't need any carrier thread that constantly polls against the database, but rather we consume the notification frames as they stream into our driver itself. And this is will be also possible with a replication stream that can be used as a logical decoding stream. And this is a neat mechanism also for other databases that expose these kind of functionality. So consuming these kind of streams through R2DBC is the most natural fit for these databases. Now, we need you. And we need you to try this out if R2DBC makes sense in your context. Give it a spin in your proof of concept. Try it out in your test applications. Perhaps do not take it immediately to production, but rather play with that. We are very confident about how the performance behaves, how the systems behave under load, but we are not exactly confident about recovery, about what if the database dies, how we can recover from that scenario to make the right thing in the sense that you will see also the errors in your application instead of hanging process. So all this stability work is still in progress, and the more feedback we get, the more of these things we are able to get rid of. If you feel that there is functionality missing, report this to us. Only if we know that there is functionality missing, we can do something about that. If you find bugs, report these to us. And as for the Postgres driver itself, the PG JDBC, which is the official Postgres driver implementation, is maintained by the community itself. And we are looking forward to transition the Postgres driver into a similar mode of operations. So if you want to get involved really deeply with non-blocking technology, with reactive programming, and you would like to become a Postgres driver maintainer, hey, that's an opportunity for you, right? And even if you submit us a documentation fixes, we are happy about every single contribution. Now, we have spoken up to this point about 3 client implementations. But there is more, and the community asks for more support, and mostly, predominantly, for support in their clients and their tools they already know. Hibernate is already experimenting with a reactive implementation of their Hibernate functionality to expose that in an asynchronous or even reactive way. But there are other projects like MyBatis, JDBI, Juke, QueryDSL, Helidon, Liquibase, Flyway, Exposed, Test Containers, and I think there are a couple of more which are already aware that R2DBC is a thing and that users would love to use these libraries in a reactive context. So if you are using already one of these tools and you want to see that happen, reach out to your favorite project, tell the maintainers that you would like to see that, vote for the tickets, get engaged with the discussion, and only by following this path we can make these kind of things happen. But because if folks do not know that you want to use their library in a reactive context, they won't really do something about that, right? Now, what about additional database? Ask your vendor. They are probably very happy to hear about that you would like to use the database XYZ in a reactive way. And only if they know about your demand, they can start working on either JDBC extensions for an asynchronous transport that allow wrapping of an existing JDBC driver, or even coming up with an entirely new driver for your database that you're currently using. That being said, if you want to get to know more about R2DBC, there's a website at R2DBC.io. If you want to get in touch with us in a quick and easy way, tweet us at R2DBC. All the code of R2DBC is open source. It is all licensed under the Apache 2 license, and this affects mostly the SPI, the Postgres H2 and SQL Server driver, connection pooling and connection proxy. The individual drivers which are developed by vendors or the community might be subject to different terms, but the core itself of R2DBC is open source. So you can have a look, you can submit pull requests, all these kind of things. There's a mailing list for R2DBC if you want to get engaged in a more deeper fashion with the community. And if you want to participate in the entire development process, there's a monthly call on every first Friday of the month. So this, the call of this month was already last Friday. And that being said, thanks for attending. I think we have still time for 1 or 2 quick questions. If you have any questions, or otherwise just find me here in the venue. Yes, question.
You mentioned Hibernate. Any other thoughts on JPA?
Okay, so the question was, I mentioned Hibernate, any other thoughts on JPA? So JPA is building on top of JDBC, and JDBC is blocking. So this blocking nature propagates across JPA itself, and JPA, I don't think that we will see a reactive JPA, at least not in the form that it is today. There's also a little bit more to that. In an imperative programming model, you have this attached session which is managed throughout your entire transaction. And there is really no place in a reactive programming paradigm where you can have this session flying around, but rather you have to ask your tool or your persistent context to provide you with a session in a callback closure fashion, so that you call a method, put in a function that receives a session as argument, and then you operate on that. And as soon as this closure is left, then the session gets invalidated. So you have also to have a change in the programming model. Cool. One last quick question. Otherwise, enjoy SpringOne.